Some ionic bonds include transition metals. Transition metals are found in the area of the periodic table known as the D block. These ionic compounds need to be treated a little bit differently because most transition metals have more than one possible ionic charge. There are only 3 transition metals that have consistent ionic charges: silver with a charge of +1, cadmium with a charge of +2, and zinc with a charge of +2. All others have variable charges that are based upon what they are bonded with. For example, in this formula, 1 copper ion is bonded with 2 chloride ions. Each chloride ion has a -1 charge, which means there's a total of a -2 ionic charge. In order for this compound to be neutral, copper must have a +2 charge. However, in this compound, the copper ion is bonded with 1 chloride ion, which has a -1 charge. In this case, the copper ion must have a +1 charge for this compound to be neutral. In each of these compounds, copper has a different charge, and each compound must be named differently so that they can be distinguished. In order to do this, the charge of the transition metal is included in the name of the compound. This is done by showing the charge of the transition metal as Roman numerals inside of parentheses. These come immediately after the name of the transition metal. These 2 compounds would be named copper 2 chloride and copper 1 chloride. Again, the Roman numerals represent the ionic charge of the transition metal. Let's look at another example while remembering that the charge of the transition metal is determined based on what it is bonded with. In this case, manganese is bonded with nitride, which has a -3 charge. There are also 4 nitride ions, which accounts for a total -12 charge in this compound. In order for the compound to be neutral, we must have 12 positive charges. The formula shows that there are 3 manganese ions. Therefore, each manganese ion must have a +4 charge. This compound would be named manganese 4 nitride. Determining the formula of an ionic compound that includes transition metals works much the same as other ionic compounds. We will follow 3 steps. First, we will write the formula and the charges of each ion, with the positive ion first. Next, we will crisscross the charges to determine the number of each ion that is needed. And third, we will write the final formula. The name chromium 3 carbonate shows us that chromium in this case has a +3 charge. This is represented by the Roman numerals included in the name. Carbonate has a -2 charge. When we crisscross these charges, we see that we need 2 chromium ions and 3 carbonate ions. The ionic compound name iron 2 phosphate tells us that iron in this case has a +2 charge, and phosphate as a polyatomic ion has a -3 charge. When we crisscross these charges, we see that we need 3 iron ions and 2 phosphate ions. In each of these cases, this results in an overall neutral charge to our compound.